Hello my dear students, this is Akash HD and welcome to the HD physics classes. Hope so you all are doing really great. So students, in this video we are going to learn how to convert a galvanometer into ammeter. Okay, remember that to convert a galvanometer into ammeter we have to connect a low resistance in parallel. But now the question arises, why we need a resistance in parallel? So remember that through the galvanometer coil, a very small amount of current can flow in the order of milliampere. So if we want to measure a heavy amount of current, a large amount of current with the help of galvanometer, we have to provide some bypass path, okay, and that is done by connecting a low resistance in a parallel. Okay, so all these things we are going to see in this video. Let's start it. So here, students, the question is, a galvanometer is having coil resistance 10 ohm, shows a full scale deflection for a current of 3 milliampere. For it to measure a current of 8 ampere, the value of shunt should be how much? Okay, so when we decode here the question, the full scale deflection current through the galvanometer is given how much here? You can see very well, 3 milliampere. 3 milliampere, or we can tell 3 into 10 power minus 3 ampere. Okay, after that what is given here? What is the coil resistance? It is given 10 ohm. And here this I will write here with the capital G. This is given here 10 ohm, and we want to convert this galvanometer into a meter to measure how much here? 8 ampere. Okay, so remember that here this I value, the current we want to measure 8 ampere. Okay, even we can measure 0 to 8 ampere any current by calculating the shunt. We are going to do it. Okay, and after that we have to calculate here anyhow the shunt resistance how much. So here I will write here RSH. Okay, so now what we are going to do here, remember that here, let's take for example, this is the galvanometer, resistance is G, okay, and through this galvanometer Ig amount of current can pass. Okay, so let's take for example what is happening that here current I is coming. So you know very well the current I, complete current cannot pass through the galvanometer, otherwise it will damage. Okay, so what we have to do here we have to connect one shunt, that means the resistance in a parallel, that is called here RSH. So in this what will happen that here through the galvanometer the current will flow Ig and the rest of the current will pass through this shunt, and here how much current is there? This current will be, by the KCL we can tell, I minus Ig. Okay, so you know very well this galvanometer and this shunt is connected in parallel. That means what will be same in parallel combination? Voltage is same. Okay, that means we can write here as voltage is same, so the drop across the shunt how much? We can write here, see, I minus Ig from the Ohm's law, I minus Ig into RSH. This is the voltage drop across the shunt, should be equal to voltage drop across the galvanometer, that means Ig into G. Okay, so from here if I will calculate here the value of RSH, so value of RSH will come how much? You can tell very well, Ig into G by I minus Ig. Okay, after that this Ig I will send downward, that means it will become here, see, G by, we can see very well, I minus Ig by Ig. Okay, can you see how we have done here? We are calculating here the shunt resistance, then we will put all these values and all. Okay, so from here what will happen that here, if I write here the value of the shunt, this value of the shunt will come here, G by I by Ig minus Ig by Ig, that means it will become here 1. Okay, now after that we will put here the values and all that. Capital G value is how much is given here? We can see very well, G is given here 10 ohm, Ig is given this one, and I is given 8 ampere. All these things we are going to put here. Okay, so this G is given here 10 ohm, I value how much is there? 8 by Ig, 3 into 10 power minus 3. Make sure that if here unit is ampere, here also unit should be ampere. Okay, minus 1. Okay, then we can write here 10 by, and here we can write here 8000 by 3 minus 1. Now remember that here sometimes we have to do the approximation. See here, as 8000 by 3 value is the very large, no? Even if you will subtract minus 1 also, not that much change will not be there. Okay, so in this situation what will happen that here this R shunt we can write here approximately how much here? 10 by 8000 by 3. Okay, and after that if I write here the approximate value of the shunt, it will come here 10 into 3 by 8000. Okay, and you can see very well this 0 and this 0 will cancel out, or we can write here how much is there? 3 by 800. Is it 3 by how much here? 3 by 800. Okay, After that, when you will simplify this, it will come here 3.75 into 10 power minus 3 ohm. Okay, you have to just simplify this here. So students, you can say very well, we have to connect here how much resistance? 3.75 into 10 power minus 3 ohm in parallel with the galvanometer coil to measure this much amount of the current. That means here the correct option is what? The correct option is here option C. So students, I hope so this video you have understood very well. Keep studying, keep going.